For 11b, we have the cotangent. So the test could have either a tangent or a cotangent, and it may or may not have a number in front of the x. So to make sure you know how to do all these different types of graphs, tangent and cotangent, so make sure you do enough practice on these. For the period, amplitude, and phase shift, you want to know the formulas for it. Your period, again, pi over b is the formula that you want to use for that one. In this case, it's just going to be pi over 3, nothing else you have to do for that one. For the amplitude, the formula is the absolute value of a. The number in front of the cotangent is just a 1, so that would be the amplitude is the absolute value of 1, which is just 1. Now for the phase shift, because it's a cotangent graph, it's just going to be opposite sine of c over b. That's the formula you're going to use. You don't want to use the minus sign that comes after it. Just this one here. The opposite sine of c is going to be negative pi over 4. And that's all divided by the number in front of the x. That's going to be divided by 3. And so you'll get negative pi over 12 would be the phase shift. So negative pi over 12 goes here. Next, we want to get the half point. So the half point is what we're going to keep adding to the phase shift to get the other key points. The half point is always your period divided by 2. So pi over 3 divided by 2, and if you flip and multiply, you're going to get pi over 6. Now to make things easier to add, you want the phase shift and the half point to have the same denominator. So to make this easier, I'm just going to multiply that top and bottom by 2. And so I'm going to use 2 pi over 12 for the half point. That way this and this have the same denominator. It's better if you have the same denominator. It makes it easier to add. So I'm going to write all these out so you can kind of see what I'm doing here, since these are not whole numbers this time and we have fractions. Okay, so I'm starting with the phase shift, negative pi over 12, and I want to add the half point, and the half point we found was 2 pi over 12. If you add that, you get positive pi over 12. Then I'll take pi over 12 and I'll add another one of these. So I'll add 2 pi over 12, so I get 3 pi over 12. 3 pi over 12, I'm going to add another 2 pi over 12, and I get 5 pi over 12. And then one more, 5 pi over 12 plus 2 pi over 12 is 7 pi over 12. Okay, so you have to add this 4 times because you want a total of 5 key points. So the first one, the phase shift, is always your first key point, and these are the other ones that you have for a total of 5. Now that you have all of the key points, we're ready to put them on the graph. So starting out here, the first key point was at negative pi over 12. The other one was at pi over 12, and then we just had to keep adding those all the way across like that. And so the next, that was 3 pi over 12, 5 pi over 12, and 7 pi over 12. Those are all the ones that we came up with that we wrote down earlier. The first one, the middle one, and the last one are the ones that get the vertical lines there. Those are our vertical asymptotes. Now the cotangent graph, we don't have a negative in front of it, so it's going to look like the original one that I gave in the lecture notes, which means it's going to actually come down and fall like this. It's kind of the negative cube-shaped graph is what it resembles. So again, you don't have to worry about the amplitude on these. The amplitude, the halfway point, it would cross here at 1, yes, and the halfway point down there would cross at 1. But on a test, I'm not concerned about that level of detail. I'm just concerned about, can you get the overall shape correct? And if you have the asymptotes and intercepts correct, then that's going to be sufficient.